Hello friends, welcome back to my channel Young Researchers. In previous videos of this playlist we have discussed about graph plotting in Origin. We have discussed about different kinetics and isotherm models, and based upon that playlist and previous history of the playlist, we are now discussing about Temkin isotherm model. So this is mainly an isotherm model that we generally apply when we are discussing about adsorption of either heavy metals, or you can say dyes or any other pollutants. So what Temkin isotherm model is about? This model basically informs us about the interactions that take place between adsorbate and adsorbent. Adsorbate is the species, you can say, like on which the which has to be adsorbed, which has to be removed from solution or any other media, while the adsorbent is the species, or it is a material or the surface on which adsorption has to take place. So what kind of interactions, either physical or chemical, and what kind of bonding, ionic or like these bondings, types of bondings, what kind of bonding and what kind of interactions will take place between adsorbing substance and adsorbate. This we come to know from Temkin isotherm model. So in this is the linear equation of Temkin isotherm model. In coming videos we will discuss about non-linear forms of each kinetic and isotherm model as well. So for now this video will be about linear isotherm modeling in Origin. So this is the linear equation of Temkin isotherm model. As you can see here, QE is the adsorption capacity, that is also known as equilibrium adsorption capacity. B is the constant, that is specific to Temkin constant, while KL is the Langmuir constant, and CE is the equilibrium concentration, that is leftover after the adsorption has taken place, or the, you can say, like maximum amount of adsorption take place. And again B is the Temkin constant, and KT is the Temkin equilibrium binding constant. So you can find their units and their complete details in different research papers on Google Scholar. So for now, based upon this linear equation, we have to plot the graph, like based upon the equation of straight line, like y is equal to mx plus c. We have to plot a graph for obtaining the constant values of B and KT for Temkin isotherm model. So for this, what you have to do, you will take natural log CE and QE values, and then you will plot the graph for Temkin isotherm model. In previous videos, in a separate playlist where we have discussed about adsorption of dyes and metals, we will provide link of that playlist in description. In that playlist, we have discussed how to calculate CE, how to calculate QE, and all these things. We have discussed each and everything in detail, and we have showed you a demo as well. So you can check the link from description. Okay. So for now, once you calculated the CE values and QE values, then you will take the natural log CE on x-axis and QE on y-axis. After that, you will select the data and go to plot. From plot, you can select, for example, scatter option. So here, when you click on scatter, then you can add borders to this graph, and you can make like other formatting, like this one Q, and then subscript. You can go here and click on subscript QE, and then milligram per gram. Okay, so these kind of formattings we have already discussed in previous videos, and here. Okay, so okay, this is the graph that is showing the linear relationship between natural log CE and QE value, and now we want to add the trend line to it. We want to obtain the R square value. So for this, we need to select okay, we need to select any of the data points here. One second, let me make it zoom. Okay, I will select any of the data points, and after that I will go to analysis here, and from analysis I can click on fitting, and here you can see an option of linear fit. After that you can click on open dialog. After that you need to click on OK, and here you can see its fitting has been done. Its R square value, slope and intercept values are shown here. And if I make it a big increase in size, okay, so this is the R square value of Temkin isotherm model, that is 0.973, and its slope value is this one and its intercept is this one. Like slope is 0.69 and intercept is 5.171. And here okay, you can edit the size and color of the line as well. This is the trend line of your graph and you can edit it according to your style. I will keep it as blue color. Okay, so this is the Temkin isotherm model and its linear fitting. From slope and intercept values you can calculate the constants of Temkin isotherm model. So here we go to its Excel sheet to see how we can calculate its constant from slope and intercept. So here you can see this is the Temkin isotherm model that we plotted in Excel. You can also plot in Excel sheet if you don't have access to Origin, but it would be better if you can plot in Origin file because it will improve the credibility and credibility of your result and also improve the quality of figures as well. Okay. So here you can see the formula of calculating BT and KT. So for calculating BT of isotherm, BT is simply equals to slope of the graph. So whatever the slope value we obtain, this will be marked as our BT value. Okay, BT, what is BT? As we have already discussed, it is the heat of adsorption or Temkin heat of adsorption. Okay, so its unit is joule per mole. And for calculating the value of KT, what is KT now? We have discussed already. KT is the Langmuir constant, and for calculating the KT in liter per milligram, we have to take the exponent, like it's the exponential form of intercept divided by BT. It means we have to divide intercept value by BT and then we have to take its intercept. So if I click on KT value, you can see also here, like in formula bar, it is written as equal exponent, and then you will make a column where you have written your intercept value and BT value. Okay, so it is the value of intercept that will be divided by G43. It means value of E column, which is the intercept. It will be divided by G column value, which is the value of B, and then you need to take its exponent. Then you can get the value of KT in liter per milligram. So from slope and intercept, you can calculate the values of B and KT. So generally the value of KT in some equations you can see this KT is written as AT. Okay, so both terms are same. If you find in some equations or some papers BT and AT, it means AT is the same as KT, just for some notation or representation of some like some parameters they use some different symbols, but the meaning behind them is the same. Okay, their unit will be same, their method of calculating the value will be same. So in this way you can calculate B and KT values, and generally the value of KT or AT value, that is a constant Langmuir constant value, is generally high as compared to BT value. Okay, so if you get this kind of high value like 1680, 1800, 600, so there is nothing to worry about. Sometimes you get very less value in you can say like in points. Sometimes you can get values in thousands or 100, 200, like this one. So but BT value, it must be less, like it must be between 0 point something to 1, 2 or 3, 4, like this one, like one digit value, not more than 100 or 200 value. So in this way you can calculate B and KT values from slope and intercept of the graph. And I hope this video helps you in understanding the basic concepts about the Temkin model. What is a Temkin model, what is its linear expression, and what those terms symbolize, and how to calculate its parameters from slope and intercept. And here you can see these kind of graphs you can plot for your experimental data, and this kind of formatting, how to bold the values, how to bold the margins and borders, we have already discussed in the playlist of Origin. In the same playlist you can check the previous videos as well. And if you have any questions, And if you want us to make a video on some other topic, do let us know in the comment section. We will try our best to cover those topics as well. So we will discuss about some more isotherms models in coming videos, and after that we will go towards non-linear isotherms and kinetic models. So till then, Allah Hafiz.